On behalf of Dell Technologies, Intel, and Carasoft, we would like to welcome you to today's podcast, focused around artificial intelligence in federal agencies, where Al Ford, Federal Chief AI Strategic Alliances Manager for Dell Technologies Federal, and Brian Carnell, Federal Chief AI Architect, will discuss accelerating artificial intelligence with data analytics.
Well, good day to everybody. Thank you all for allowing Brian and I to join, and thank you for your time and listening to us. My name is Al Ford. I'm the Federal Artificial Intelligence Strategic Alliances Manager for Dell Technologies Federal. On the phone with me as well is Brian Carnell. He is our Federal Chief AI Architect. So between the two of us, we work closely with government customers. We work closely with federal system integrators, and then also with our federal partners, such as our reseller community that broadly supports the federal government as well. So I'm going to share with you some of the topics we're going to discuss today. And if you have those questions, feel free again to drop those into the Q&A, or feel free to save them toward the end, but we'll definitely leave time for discussion at the end. But between Brian and I, we have a couple of primary responsibilities. Number one, to understand the Dell Technologies AI capabilities and portfolio, and then also help technology partners like Intel and others, smaller Intel ISVs, to develop solutions with Dell. The second responsibility we have is to help deliver the message and the capabilities and provide these capabilities to the federal customers, the VAR community, and the system integrator community for all the federal marketplace. So with that said, Brian, I'm going to turn it over to you real quick, just say hello, and then we'll get jumped in and share the agenda.
Awesome.
What
Thanks,
are the
Al.
different types of artificial intelligence, and what are a couple of examples of those, and to kind of help think through how these artificial intelligence techniques can help in a given mission environment. Another area we'll discuss is, and we get this question a lot, so we want to make sure and share it, is what are the different roles that you need to deliver artificial intelligence, specifically human roles? Where are the human process? What are the types of experts you need either in your organization or part of a contract that can help deliver artificial intelligence into your mission programs? And then how do you get it done? I mean, so it's one thing to prove out artificial intelligence, but how do you incorporate it into your existing operations? We call that delivering artificial intelligence ops, AI ops. And then one of the processes we go through a lot, we get most of our questions around, is what is the right accelerator to use? What are the types of accelerators that are out there, and which one should be used for my particular mission? And then if we're able to get to it, the rally cry I think that we share, that Brian and I share with everybody, is let's get it to the edge. So we want to help you take it to the edge. And this is where a lot of the innovation from Brian and I's perspective is coming right now, is delivering the artificial intelligence capabilities to the edge and at the edge. So hopefully we'll be able to get to that and discuss that, and then before we jump into your questions. So Brian, with that said, I know there's been a lot happening in federal for the last 3 years. There were lots of policies initially. From your perspective, what are some of the things we've seen over the last 3 years, and how has it evolved?
I would say the biggest thing that I've seen over the last year is the digital transformation. So last year obviously was a crazy year for everybody. Work used to be a place that we went to. Now it's a thing that we do. Dell's always been a very dispersed organization. So internally, we use a lot of artificial intelligence to measure our traffic, where it comes from, where it goes, where we need to bolster circuits, where we need to do changes within our infrastructure to meet the changing demands of our workforce, because we are so dispersed. In federal agencies, this was a new concept for them. So one of the things that we saw last year, and I think that really moved artificial intelligence to the forefront, was the ability to change and speed up that digital transformation that they already had underway, using some of the artificial intelligence techniques, using data gathering, looking at the types of data, looking at what historically they had. I'll break out of that for just a second to say that I look at data in two ways when it comes to artificial intelligence. It's either immediately actionable or historically valuable. And not all data that is historically valuable is immediately actionable, but all data that is immediately actionable is historically valuable. So when we're looking at what the government's doing, a lot of the historical data that they currently have that they didn't know was valuable, they are now tapping into that data. So one of the biggest things and one of the biggest trends that I've seen now, just off the top of my head, you kind of corner me with that question, but just off the top of my head is the digital transformation strategy and how it's sped up last year in moving to the remote workforce and then applying artificial intelligence and machine learning to the data that they currently have and to help them better manage the dispersed workforce that happened during COVID pandemic.
Yeah, a lot has happened, and it's been interesting to watch and be a part of. And it's made our roles even more, I would say, fun and enjoyable as we collectively try to tackle these issues. 3 years ago, Brian, I can remember when I actually started in this role, there were a lot of just trainings going on. What is artificial intelligence? I think everybody's definition of artificial intelligence was defined by what was on TV or they saw in the movies. And so it really was, well, how am I going to take that capability from the screen and implement it into what I'm doing for governmental practice and work? So it became, I did a lot of training initially. There were a lot of people interested in the different types of artificial intelligence capabilities that would help them, tackle some of the problems, in the government. And I think the next thing that really happened was I think a lot of the departments and agencies really figured out that they need somebody to head and work with data. So they put a lot of chief data officers in place. They put policies in place to require departments and agencies to put them in place. And then a year later, I know that those chief data officers had to start putting some structure behind it and delivering, just data strategies overall. So any final thoughts on this, by anything else that you saw over the last 3 years?
Yeah, one last one is I think you kind of touched on it, but the operationalization.
Mm.
So moving from all those skunkworks projects that exist out there and then really buckling down and applying the resources to turn them into operationalization of their AI practices.
Yep. Yep. So we'll transition now to talking a little bit about artificial intelligence, machine learning, deep learning, but more importantly, a couple of different types of AI and where we're seeing those. And we'll talk a little bit about natural language processing and then computer vision as well, or CV, as other people may have heard of it. But effectively, artificial intelligence is a broad category. Machine learning is a subset of artificial intelligence, and deep learning is even a subset of machine learning. So you could broadly fit artificial intelligence, machine learning, deep learning underneath a category for just advanced analytics. So that's really where all these capabilities fit. But when we start talking about the practical application of artificial intelligence, we are talking about things like natural language processing and computer vision. Brian, if you don't mind, let's jump into natural language processing or computer vision, whichever one you want to jump on first, and let's discuss what it is, and then we can move into, how it may be applied in different government scenarios.
Okay, let's start with computer vision. Computer vision is essentially giving your computer eyeballs. So allowing the computer to use a video stream or a video camera to look at what's in its field of vision and then classify on that. And there's two ways to do that. The first is a centralized version where you're looking for everything that's in its environment. It's where GPUs specifically fit. They have a big wide range of parallel processing that allows them to look for many multiple things and then distinguish what's in there. And then there's inferencing. So this is what we're seeing most agencies utilize right now is the inference model, where they need to look for one or two or maybe even 10 things that are in the computer's field of vision that they've pre-trained for, that they've pre-trained their algorithm, and they need to do it really fast. The example that I use a lot when it comes to computer vision or processing at the edge is kind of radar. And for a long time, we've been flying planes and we've been looking ahead with radar. Is there something in the path? Is there something I need to know about? And it's a very easy use case because in the sky, there's not a lot of things. Other planes, maybe, or maybe a bird here and there, but radar allows them to see those things. Now, what we're seeing is a trade-off where computer vision is looking ahead. So maybe in clear visual skies, the plane has a camera mounted in front of it. It's looking ahead, whether it's using hyperspectral analysis, whether it's using clear forward-looking infrared, but it's looking for things in its path and it's making decisions on its own using an inference model. So to do that, you have to do that really quickly. And there are some specific technologies that have been out there for a long time. I don't think we called them artificial intelligence in the beginning, Al, but they certainly are that. And that's field programmable gateway arrays. So taking your inference deep learning or computer vision model that you created, moving that algorithm to the edge, and then looking for those things using computer vision, and an FPGA gives you speed and ease of use. And then natural language processing. One of the things that we're seeing a
Brian,
lot.
let me give, if you don't mind, let me give one other example there of
Absolutely.
computer vision. As you're talking about that, you're talking about looking at through things, that inferencing engine through perhaps a camera or a closed circuit TV. I know we've been working with different companies as well that have campus safety, whether it is a campus that's a governmental campus or a base, or whether it's a college or a school. One of the things that one of our technology partners has built out was the ability to look for somebody perhaps that might be carrying, a harmful weapon. And so that can be then quickly identified, and then the right alert notifications can be sent to the security groups, and quickly, before anything occurs, be able to address perhaps that scenario. So another example there of computer vision, but how it protects all of us and keeps us, even safe. So, but thanks, Brian. Yeah.
Yeah, that's a perfect example, Alan. I know exactly the alliance partner you're talking about.
Yeah.
So they even, in one of the computer vision applications, they were even able to identify a firearm that was under a shirt because of the shape that was pushing out on the cloth itself. So using that particular application, they're able to keep campuses more safe. They're able to detect threats before they become real problems, and they're able to address them almost in real time. And it's something that, you can't have one guy sitting there looking at 50 computer monitors and pick up on those types of things, but you can install a model and you can have artificial intelligence look for that type of stuff and then alert on it as well.
Yep.
Yeah, good call out.
Yeah. Yeah. And so let's go ahead and move into natural language processing.
Okay.
I'll let you kind of tee it up a little bit, and then I'll talk about one of the use cases out of our HPC and AI lab.
Okay. So with natural language processing, the thing that we're seeing is like National Archives recently put out an RFP that we were invited to participate in. And they are using natural language processing to go through the reams and reams of paper that they have and to come out with answers to common questions. So the National Archive wants to digitize their entire catalog and their entire breadth of knowledge or knowledge base, if you will, that's on paper. And then what they want to do is when someone, and this is available to find on the internet, when somebody logs in and asks a specific question, they actually want to do sentiment analysis on that to help narrow down what that person might be looking for. So the good example that you always see on the internet a lot is somebody shopping for umbrellas. So I want to look for an umbrella, and I might be coming from this geographic region. I know that based on other data points that it's raining in that geographic region. So if they're asking for an umbrella, likelihood they're just looking to find one that they can go and get. Or if it's a really sunny area, they might be looking at it because they don't want to get skin cancer. They want to try to avoid UV rays that are hitting them during the day. So sentiment analysis and what somebody's looking and searching for, they want to better understand, and they want to apply that to their book of knowledge or their base of knowledge that they have that they're digitizing at this point.
Interesting. So, well, thanks for that. One of the natural language processing items that are the Dell Technologies High Performance Compute and Artificial Intelligence Lab in Texas has undertaken is the ability to listen to speech, turn that speech into text digitally, be able to take that text and search for an answer, and then turn the answer from a digitized response to a digitized voice, a synthetic voice. And they've been able to successfully do this. And so people say, well, that's great that you can listen to somebody's speech and get an answer and then give that synthetic message back. But what would be a use case for that? In this case, one of the things they would like to do is turn perhaps maybe a Michael Dell voice or a bot, a chat bot, and put it onto a screen, perhaps in a mall kiosk, that individuals can go and start inquiring about Dell Technologies products and solutions through the Michael Dell bot. So all these capabilities are possible, and we're making it happen through these different labs. If you apply that to government technologies and use cases, there are lots of ways that the federal government interacts through its departments and agencies. This might be an effective way, and I'll turn it over to you, Brian, to kind of share maybe your thoughts on this, but having the natural language processing and the speech to text and text to speech could be a great way for the federal government to interact with its constituents.
I'll just tag directly onto the end of that and carry it even a little bit deeper in that things like Section 508 compliance, being able to share corpuses of texts in a compliant way, all of those things can be addressed using natural language processing and artificial intelligence. Back to the sentiment analysis, if you want to carry the sentiment analysis and the results of that corpus of text search all the way through to compliancy, being able to use NLP or natural language processing to read and answer and then interact in a way that is compliant with the American Disabilities Act. That's a very good use case for this as well.
Interesting. No, that's fantastic. And again, just reaching to all the constituents, not just those that can speak or talk through a telephone. So that's fantastic.
Exactly.
So I know, Brian, one of the questions you and I get quite a bit are really, what are the roles and people roles that are needed within a department or an agency, or perhaps even in a system integrator or a value-added reseller? What are some of the roles that people really need to consider to deliver artificial intelligence into their mission? What we're showing here, if you're able to see the slide, is really a sales tool that Brian and I provide to our Dell sales teams, to our partners, our reseller and system integrator partners to use in discussions with federal government customers. And it really asks just a set of high-level questions to really help identify initially perhaps how Dell Technologies or Intel or any one of our other partners can help the customers on their missions or their programs. Baked within these questions are three different roles that the Dell corporate Office of the CTO has identified to assist with customers that really want to deliver AI in their capabilities. So the first one there is actually that second question. Do you have a data scientist with a skill set that can manipulate or work with data? And quite simply, and I tell you what, Brian, I'll turn this over to you. What is manipulating data? What does that process look like?
Sure, there's a couple different things, and the first is that they need to be able to spot and graphically visualize data and then represent that data in a graphic visualization. I don't believe that just handing over spreadsheets or access to database where somebody can go and run a query and get back a big long text string is even viable anymore. Most of the business folks inside of an organization that are looking for data scientists to do something, it's all about visualization, visualization, visualization. So being able to pull the nuggets out, being able to decipher what data is available, helping the organization ensure they have a good data and governance process, and then ultimately creating those visualizations is where your data scientists really come into play.
Got it. So that's great. And so just really having that person that really understands data and the value of the data, but yet then, no more importantly, how do you manipulate that data to make it usable, right? So then the second role happens to be a data scientist as well, but it is entirely its own role altogether, right? Brian, talk a little bit about the data scientists and how where they might find an algorithm, perhaps, or how they might develop one, write one, or what do the algorithms do for artificial intelligence?
So for artificial intelligence, the algorithms are looking for something. Generally, you're taking your data, you're adding metadata to it, you're creating bounding boxes, and then you're saying, I want to look for this bird in my drone's field of vision. And that data scientist has to be able to grab the data, categorize it, and then label it correctly so that if a giraffe pops up in the picture, it doesn't tell you that it's a bird. So being able to develop the algorithm, being able to get the data correctly, and then being able to run the compilation of that data on your computer to create your algorithm is really where the data scientists come in. The biggest understanding um, is that data scientists are oftentimes pretty darn good programmers as well. So it's not always the case, but a lot of times your data scientist, the person that has the wherewithal and the logical mind to manipulate data, also has the same logical mind that allows them to create the scripts and to create the algorithms that you can then exercise, whether you're using natural language processing or computer vision.
Very cool. Thanks for that. So that's the first two roles. The third role is really an IT specialist with knowledge on artificial intelligence infrastructure. So this really is quite a bit different than a data scientist, and it's quite a bit different than your typical data center expert that's been working in IT for the past 20 or 30 years. Brian, what's some of the differences that the new IT operations expert needs to know when it comes to working with artificial intelligence infrastructure?
Throughput. That's the big thing that your IT specialists need to know is how is the data going to be used? What type of data? And then how is that data going to be accessed? So one of the things that I've seen in my history, I was a federal employee for a long time. One of the things that I saw was that we would just grab the next IT guy in line who was willing to just jump in, and then we put them on a project or an artificial intelligence or machine learning project that probably wasn't within their wheelhouse. So having that logical data science driven type IT specialist will pay dividends for you. And the thing that I will throw out here, because it's kind of a segue into something I know that we wanted to cover today, and that's how to operationalize your IT and picking a known good infrastructure. Your IT specialists are going to be really good at putting together a known good infrastructure and then exercising against it. So whether that's a framework, whether it's the underlying physical layer such as the compute or the memory or the type of hard drive, SSD, they're going to be really good at putting together those components and matching them to what the organizational data strategy is, whether they're doing NoSQL, whether they've got relational databases, whether they're streaming data. No matter what that is, your IT specialist is going to know what's available in the organization. They're going to know the underlying infrastructure, and they're going to be able to pick from one of the AI ready architectures that allows them to marry that seamlessly into their existing infrastructure and give access to the data scientists so that the data scientists don't have to go out and become experts to help recommend the hardware. Your IT specialist is going to know that infrastructure upside down, and they're going to be able to marry what they have today with where they're headed.
Yep. And you and I both know, Brian, we worked with the Department of Energy, and they shared with us that they've had no less than 40 different companies come to them with new accelerators that were becoming available and wanted to share with them these capabilities. So that AI expert for the infrastructure is definitely needed to parse through all those capabilities. So I know, Brian, you just brought this up, so we'll go ahead and move on to one of our next topics here, and that is AI ops. One of the things we continue to see from our customers in the federal marketplace is a lot of them have started their skunkworks projects, and they've been able to train models. And they said, you know what, I've got a really cool application now that trains models and delivers an inferencing engine for me. But they said, now I can't integrate that into our overall DevSecOps, SecDevOps, however they want to term it, into their AI operations. Brian, talk a little bit about some of those challenges and some of the things you've seen as customers have tried to incorporate AI into their overall IT operations.
As Al mentioned earlier, the Skunkworks projects, we've seen just thousands of those where where a customer has spun up a small project. They've applied a data scientist to that. They've cobbled together an infrastructure, and the data that they receive from it and the performance and the return on investment they receive from just that pilot project was enough to convince them to move on, to operationalize this, to get it out and democratize what they had created to the entire organization so the entire organization could benefit from it. The thing that we always try to lead with up front, and I'm going to go back to that data conversation again, is they have to know the type of data they have and they need to assess what they have available. And then they have to look at what the infrastructure is. This is that IT specialist. As it exists today, do they have a ton of technical debt that they're going to have to work around? What is their plan to move data from the edge to the core, from the core to the edge? And I think we may get into some federated learning. I don't know if Al will lead us there or not, but if we do, we'll talk about that. But what is their as-is infrastructure and what do they need to operationalize? So we know it works really well. We know this project worked really well on this computer under my data scientist desk. Now I need to make that available to the entire organization. What does that look like? And then building up in Al's stair-step chart, building up the right staff at the scale you need to go to the organization. And then finally, looking at an AI-ready type of infrastructure or solution versus cobbling something together. I can tell you, Al, when I did my first AI project, I spent countless hours on the internet, blogs, reading anything I could get my hands on, trying different frameworks, trying to figure out what's going to work together. And even though I may read on one blog or one post or one white paper that a specific technology worked and give me the brand name of the technology, TensorFlow, it didn't necessarily match with the database that I had in the back end because there was a version difference. So even though what I thought I had worked and what everything I read said worked, it didn't because there was a simple version mismatch, which may have had a bug fix or something applied to it. So accelerate what you know and what you want to accomplish by taking that guesswork out and applying an infrastructure that is known good, that works with the framework that you have chosen, and that works with your knowledge base. So if your folks are TensorFlow experts, that's what they use in their pilot project. Make sure you pick a framework and an infrastructure that's going to work with TensorFlow.
Gotcha. Well, thanks for that. And we've seen this struggle, right? As people have said, "Oh, I can do this," but now again, they've got to operationalize it, and that's really part of the democratization of AI, right?
Yeah, and that, like you said, we've seen just so many that say, "Oh my God, this worked so well. My Skunkworks project was awesome, and it just worked, and I've already know everything I need." And then they toss it out into the larger organization, and it doesn't scale. It doesn't fit. So just taking that piece of guesswork out by picking that known ready infrastructure with a known ready framework and a known ready stack that matches the skills within your organization is so valuable. Every CTO that I go visit or CIO that I visit with, that's the first thing we talk about is what data do you have? Is it, do you need to discover immediately actionable or are you looking at historically valuable? And then what skills do you have? Now let's match your infrastructure to that to make sure that you get a framework and your data scientists start trying to figure out how to cobble together stuff to work.
Yep. So, Brian, I think what you just shared was, really it talks about, the customers and asking, and even system integrators, I've got a use case for artificial intelligence. I have an idea and a direction I want to head, but how do I get started and where I start? So a lot of these conversations we then have, and O'Brien, we talk to the customers and we say, well, let's start figuring out, let's find out a little bit more about your workload. Let's talk about your data sets, and then let's identify the right accelerator for you to start developing on. And so a lot of those typically start with even just a simple CPU. So Brian, my question to you is, with so many different options that are out there, what are some of the questions you might ask a customer, or just to help kind of narrow down what type of accelerator they need?
First and foremost, is it an edge use case, something that's immediately actionable? Are you trying to drive a car, or are you trying to pick out a manufacturing defect in your next jet engine part? And Al, I just got off, I was just on the call with the group that's building the spindles for the jet engines. And we're going to use a camera to real time look at the spindles and the shot peening process to figure out if they got good coverage in their shot peening to make the metal flexible. So in doing so, that's a very fit for purpose edge use case. And we don't have to look at 1,000 different things when you're driving a car. So if you're driving your Tesla down the road and you need to account for a giraffe, as I mentioned earlier, that might run in the road, you want to be able to do that. But for this particular use case, this particular edge use case, we're going to be looking for one specific anomaly. And that's where the machining lines, the lines that are created by the turning of the part, are not interrupted by a shot peen or a dimple, like in a golf ball. When they shot peen something, they create dimples in it, just like you have on a golf ball, and it allows for the stressors in the metal to allow the metal to flex versus being brittle. So we're going to look for something very specific, and that is a line, a machine line that is longer than 2 millimeters. And if there's not a dimple within that 2 millimeter line, then we're going to have to stop, take that part out, put it back through the process, the shot peening process again, and let it go back through the quality assurance. Right now, they have a person that stands there with basically a jeweler's scope, and he looks at it and he says, okay, I don't see any lines that are longer than a millimeter based on my knowledge. That is a point of failure because he could miss something. It's a pretty big part. It's not a small part. But for computer vision, it's super simple to pick out. It's super simple to measure. And we can do it at speed and scale using an FPGA and an inference model at the edge that changes the dynamic of how they do it.
Excellent. So let's move into our last topic, and that really is what Brian and I are going to recommend to everybody in the audience, and in the action. And the action is to get to the edge. As we've been discussing, we've seen thousands of projects where skunkworks projects or programs or missions that have been able to train models and develop an application that can look for whatever it is you've trained that model to look for. So we'll talk about the predictive maintenance and the use case and the outcome here in just a minute. But again, the goal here is to remind everybody that the edge is where this is headed. Some people are really starting to get there, but there's a lot of requirements at the edge that really need to continue to be built out. So this is still a very bespoke environment. There are a lot of requirements that are different for every single edge outcome that's needed. So it becomes a challenge to find the right compute in the right size, weight, and power or swap capabilities, and then be able to put it into the locations that you need these capabilities to operate. So let's take a step back and let's remind everybody again, it's about that data. Artificial intelligence needs new and fresh sets of data. Otherwise, the trained model cannot get better with just the same amount of data or a static data set. So it's really the edge where all this new data is going to come from. And then when you apply those inferencing capabilities to look for the things at the edge and truly utilize artificial intelligence for the two things that I always share that it does. Number one, create a more accurate decision. Number two, reduce time to decision. And again, that's all happening at the edge. So I'm going to reiterate again, the action is to get to the edge, start thinking about the edge. So Brian, what are one or two of the partners that we're working with as an example on how they're helping us solve some of the edge problems? Let's go with one for now.
Let's go with Lucid. So okay. One of the technologies that we've built out, and I think we've actually got it skewed up at this point, is a federated learning platform. And the airplane that you see in the picture in this particular predictive maintenance use case was the first use case for the federated learning process. And federated learning is kind of that democratization of AI. So if you think about how federated learning works, if you guys have a chance, you can go look up KubeFate, KubeFate. That's the underlying technology or the underlying theorem for federated learning. And in this particular use case, what happens was the plane had so much data that even maybe it was on the ground for 5 minutes, 30 seconds in the case of a military aircraft, or 3 hours in the case of a long haul overseas flight where they load and unload. They couldn't move the data. They couldn't move the data in time to do any sort of artificial intelligence against it. Not simply because there wasn't a bandwidth, because they did have bandwidth, but simply because there might have been latency introduced that they couldn't account for in their network. There might have been 2 or 3 planes that landed at the same time. So what they did was they offloaded the data at intervals where they could. They created a predictive maintenance model, and then they pushed that inference model to the edge. So then as the plane was flying, the edge processing platform was running against that inference model. That inference model never saw the actual real data that was pushed to it. So it was homomorphically encrypted. And then when the plane landed, only the algorithm updates themselves were moved back to the core where they could be added to the algorithm in the machine learning rinse and repeat cycle. So they saw a plus 99% save in bandwidth and efficiency, and it allowed them to turn a new algorithm back to the plane during its touchdown time. So just the savings and just the leapfrogging of technical debt alone and that unpredictability of network bandwidth and traffic using a federated learning model gave them the ability to only move the algorithm back and forth, and it gave them security, it gave them speed, it gave them agility, and it allowed the plane and the edge platforms that were loaded on the plane to do the number crunching prior to the plane even landing, and then only move the algorithm itself.
Yeah, and I think in this particular use case, Brian, if I'm not mistaken, they were keeping track of all the parts and components that helped that airplane run. And as things were about to fail, they would know those predictive indicators. And so before the plane would land, it would have already been able to forward signal down to the ground what part was needed and what technician was needed to show up and be able to repair the plane during this next layover. So I know that's the ultimate end use case, but thanks for sharing some of the details on the behind the scenes on how that actually worked to build out. So again, another great example, but thanks for that.
At this time, we'd like to open up the floor to any questions. It looks like we have a few already queued up here. So one of the questions we had is, you hadn't mentioned any cyber in any of the use cases. Are you experiencing many requests for AI in cyber?
Yeah, absolutely. So quite a few actually. Cyber has long been about logs and really focusing on logs. But with artificial intelligence in cyber now, you're able to take a look at vast amounts of large data sets. Think of just the massive large data lakes that are out there. So whether those are indicators from keeping tabs on your network and security, or whether you're trying to determine if an attack is currently coming in, there's multiple thousands of ways you can take a look at utilizing artificial intelligence to quickly detect those. Brian, I'm going to let you talk about, so we won't name them in particular, but one of the partners that we're working with to help solve this challenge for cyber utilizing, neuromorphic capabilities.
Okay. So I'm gonna run deep on that because I know exactly what you're talking about. The use case is the scene, and they're taking in petabytes of data a day from all the various systems that are out there, all the logs that are coming in across their product. And they are unable to process those logs and unable to process data fast enough that they can keep up. So what's happened is that whenever they create an index or a look or a query into the data, it's striped across so many different hard drives out there that the query takes forever to come back. So it's almost unusable in the current situation in that they have so much data that when they try to index it to get an answer, the cyber event has already passed. It's over. They've already solved it. They've had a person that sat there and just dealt with it. What we're looking at doing right now, and the original proof of concepts have yielded really good data, is we're going to index every single drive using an FPGA. So every SSD will have an FPGA tied to it. As the data is put on that drive, that specific drive will be indexed. So the wider you go in normal indexing, you get more and more latency. In this particular case, the latency is only the size or the latency of that single drive. So using neuromorphic computing and an FPGA, we are going to index the drive. And then if you have 50 drives and the index time on one drive is 25 seconds, that's what it's going to be for all drives. That's a really good use case for AI and neuromorphic in the search and in one of the particular problems that we're trying to solve right
That's awesome. Thanks, Brian. Natasha, was there another question?
Yeah, I think you might have touched a bit on this, but how does Dell assist or help with proof of concept?
In a variety of ways. Again, one of our largest partners being Intel, a lot of times we tackle proof of concepts along with partnerships like Intel. Perhaps we work with a federal system integrator or another value-added reseller as well, but we come together and bring multiple sets of resources to set up proof of concepts. We also get a lot of questions from customers about, well, how can I try before I buy? And so we actually utilize Dell's high performance compute and artificial intelligence lab in Austin, Texas. And throughout this pandemic, we've actually been able to allow customers to remotely access over 13,000 square feet of data center, compute, networking, and storage so that they can try these capabilities out remotely, making sure that what they think that they're buying will work for them. They test it out, and then they're able to say, yep, this works. And a lot of times we can help them even tighten up their software stack. So our experts in our HPC and AI lab are fantastic at taking on these challenges and these proof of concepts and then handing it back over to the customer saying this will work. And then the customers feel a lot more confident, not only that in the equipment that they're acquiring, but they feel confident that they can recreate that environment once they receive their equipment to work on their locations.
Great.
We have one more question.
Yep, it looks like we have one last question. What are some of the most interesting use cases you have come across?
Brian and I have talked about this past year and the challenges it's represented, how it's really brought AI to the forefront. I think one of the most interesting use cases was using technology, specifically AI, to address the need for better COVID testing or COVID screening. And I tell you what, Brian, I'll let you kind of address, at a high level, some of the way these technologies are working, but we've worked with no less than 3 companies on their approaches. But so Brian, I'll let you kind of talk about at a high level, how AI and the technology is really helping to work to solve these problems, both hopefully sooner, but definitely in the future.
So the use case I believe that you're talking about is the COVID detection with hyperspectral analysis. The companies that came to us pretty much all came to us because they had a problem of processing all of the images that they were gathering, i.e. they had so many images and they were so compute intense that they didn't have a way to process them. So they needed to figure out what the infrastructure they needed was. Since it was during the pandemic when these things happened, what we did was opened up our lab supercomputer to them and gave them access to it so they could process images. One of the groups was processing about 4,000 images a day. Once we opened up the supercomputer to them, they were able to process about 40,000 images a day. The technology that they were using was they were spraying or they were taking samples of saliva and they were looking at the saliva with a hyperspectral camera that gave 3 different light spectrums and 3 different views of the sample. And then from that, they would reconstruct a 3D image to pick out the proteins with spikes that were COVID. So using that particular methodology, they had to take all 3 of those images. They had to process those images. They had to then create a 3D image from those 3 separate hyperspectral light analysis or hyperspectral light rays to then go and use computer vision to detect for COVID. So once we were able to run that through our supercomputer in the lab, which, by the way, everyone on this call has pretty much access to, get in touch with Al or myself, and we will, if you have a project that requires really testing proof of concept, we can apply the resources in our supercomputer lab to that. So doing that allowed them to get to a inferenced model a lot faster and then utilize that inferenced model at the edge to do edge compute and to look at the samples as they were inserted into the machine and then pull out from that the samples that had COVID. And it would give a positive or negative if the computer vision recognized a protein with spikes that fit the algorithm or the image that is COVID.
Thanks, Brian. Hopefully that addresses the questions, and thanks for those. Appreciate it. And really want to thank everybody for your time today to be able to listen in. Again, if there's anything Brian or myself can do to help you in your mission or within your company or organization, please let us know what we can do to help. Natasha, thank you very much.
Thanks for listening. If you'd like more information on how Carahsoft, Dell Technologies, or Intel can assist your agency's mission to artificial intelligence, please visit www.carahsoft.com/Dell or email us at delltechnologies@carahsoft.com. Thanks again for listening and have a great day.